Hey everyone, I am back again with the second fan with my newly built test rig. This time, this is a Windward by Tat, or Wing Tat. I'll go up to the lower canopy. This is another Windward. And you can see it's got the Wing Tat canopy, or the Tat canopy. And the electrical information is right over here. See what it says. Let me get up higher. And let's see if I can get this thing to focus. .68 amps. That's what the current draw rating is, so we're gonna see what we actually get for an actual current draw with this motor. So there again, this one also is just like an industrial, like that Contec there, that's an industrial. This blender fan, this would be just a spinner. This is a residential, but it does not have a pull chain or switch housing on it. So we're going to do the same thing with that amp meter, capacitor decade box, switches to add capacitance, 10 microfarads, 20 to go with the decade box, high to send straight line power to be your maximum current draw, and then I got solid state variable speed control. So we're going to test this to see what wall control would actually be good for this fan and what would not. So starting with 0 to high to test its inrush current. 0.82 was the maximum current rush, and it is dropping down to 0.76 as it's speeding up. .75. Okay, so 0.75 amps is actually what this fan is drawing. What it says it's rated for is not always quite the same as what it actually draws, so I don't know if the capacitor was changed in this. I should actually test this, but so far it's a reasonable high speed. It's not insane. I mean, it's pretty fast, but it's not like overpowering or too slow either. Let's see what kind of air. Oh yeah, I get a good amount of air on this one too. And then I'm going to test to see what kind of air movement I get back here. Hey. Okay. Okay. It's not bad. I wouldn't mind this fan. I would hang this one either in my bedroom or in place of in that spot where the blender fan is. I wouldn't mind it. It's perfect for that. Okay. Since we got our high speed, time for spin down. And there again, spin down is useful for knowing whether the bearings are bad. If it spins down and it doesn't stop too quickly, like as if it were to have a brake on it, then bearings are good. Sometimes a little abrupt means bearings might actually need to be treated a little bit. But I don't hear any bearing noise in this one, so this one might also stop a little bit abrupt at the end just because it's got wood blades on it. I know like steel blades on an industrial tend to cause it to have long spin downs. So this one's got the spin down of a residential. Okay, time to do the decade box, and we're going to see where this thing starts and how much current draw it gets. So, 1, 2, 3, 4. Did it start on 3 or 4? I'm just going to let it. So 1, 2, 3. Okay, it starts on 3, but is it going to stall out? I don't think so. That was a little too quick to 4, so. And it's drawing 0.13 amps. Oh, it stalled. Didn't look like it, but it stalled. So I go up to 4. And it's drawing 0.18. 5. So it might take a little more, and it's drawing 0.23 amps on 5. I'm going to see if it gets up to speed. Okay. It's an aesthetic low at 0.23 amps. Here's 6 with 0.28. We'll see what kind of control this uses. 7 with 0.33. Here's 8 with 0.37. Might be able to use a 5/813 on it, so we'll see what it does when I get up that far. So this is 8. This might be a little too fast for a low on 8/12/20. This is like a low medium, so here's 9 with 0.42. 10. 0.46. 11 with 0.51. 12 with 0.54. It's flopping between 0.54 and 5.5. So this would be low medium on an 8/12/20. 13.57. I think maybe either 14.6. I think I do have a control that would be best on this one, and that would actually be a 6/814. I think a 6/8, so this would be high medium on a 6/814. I do happen to have one of those controls in the drawer, so like if I put this fan anywhere, I'm going to put that control on it. Here's 15 with 0.63. 16.65, 17.67, 18.68. That's what it was. 19.7, 20 at 0.71. So I'm really close to high. So I don't think an 8/12/20 would quite be the control I would use. Its high is just a little too close. Yeah, there's not exactly as much difference. I just flipped it to high. So, just for grins, I'm going to just kind of go through. I'm at 23.74. Okay, I'm at 0.75 right now on 24. Will I go over 25.75? Oh! Okay, 25 is the max I can go, so I'm safe with an 8/12/20, but it's still too close to high. But At 26, I draw 0.76. So I am actually over on 0.76. Yep, you hit a resonant frequency right there. Yep, you're over. Okay. I'm going to go up and stop it. All right. And now I'm going to do the variable speed control solid state. Let's see where it starts. Let me just set the camera. I just at least rest it so my hand doesn't get fatigued. Okay, just got it started at just a hair over 3 o'clock and it's drawing 0.2 amps. Now let's turn it up a little. 0.25. I hear a faint hum, but that's another choice control I might be able to put on this fan. This Wing Tat here is a solid state variable. It seems rather quiet. I'm going to turn it up a more. 0.3. Now I'm already at low medium with it. I hear a faint hum, but not much. I could almost use this in the bedroom on a solid state. This is one that's actually the quietest fan I've ever encountered with a solid state. I'm going to turn it up. I'm now close to noon at 0.4. This is definitely a living room. Never gets louder as I turn it up, so this thing works beautifully on a solid state. I think this type of motor, this Wing Tat, is meant to be on a solid state. 0.65, and I'm just going to bring it right to high, and I get 0.73 on solid state high, so a little bit under straight high. So that is actually all for this Windward Wing Tat spinner fan, and I will see you next time with another fan. Thanks for watching.